In the past, I've made a quest system, but now that we're doing a lot of stuff with state trees, I wanted to make a much more approachable state tree based quest system. So we have an actor here that will give me a quest. I have a quest menu, it's empty right now. If I overlap with this, I now have your first quest, circle and stand on the ramp. And as I do that, you can see that these things get marked off and new objectives become available. Stand on the blocks and jump off into this overlap trigger, which can trigger a reward or whatever you want, and in this case even gives me my new second quest, which is redo the first 2 steps. So we do that, and then we get another reward, and the quest list is empty now. This is all based on a state tree system, so we have our quest laid out in a state tree where we have a task managing the quest itself, and then every set of objectives is a state in and of itself. We have a bunch of tasks that make these individual objectives, and then we have a task that manages those objectives and checks, hey, are all of them done? And if so, we move on to the next one until the quest is finished. So that's the basic setup of how this is going to work. We're going to go through this one step at a time and make this from the ground up. So here an entirely empty project. If you want the finished project for the entire series, or maybe just any individual part of the series, there's links down below in the description for YouTube members and patrons to get those downloads under every one of these videos. First things first, let's go into the plugins and look for the state tree plugin. It's called Gameplay State Tree. You want to turn that on because we're going to be making use of gameplay state trees. So restart your engine and we can get started. So let's get started with making our first state tree. I'm just gonna look through here, state tree, and that will be a normal state tree component based one. And we'll call this something like quest 1. Now we're gonna set up a couple of objects here that we need to start working with to make this actually work. The first one is going to be a quest giver actor. You can technically put this on any other actor that you want, but that's going to have a handful of disadvantages down the line. So I like to just make a specific actor to hold the quest, and then any other actor can just reference this quest giver. So let's call this quest giver, and just to keep a good naming convention, BP, quest giver. That is going to have a state tree component. By default, it will start its logic automatically. We're going to turn that off, obviously, because we want to explicitly start this when we actually want to start it. For now, what we're going to do is I'm going to just add a box collision to it, just like I had in my preview at the start of the video. We're going to set hidden in-game view off so that we can easily find it, and then we just on overlap cast to third-person character as a quick and dirty way to check, hey, are we overlapping with the player character? If so, take our state tree and we start logic. Now, there's a lot more to do here later into the process, but for now, this will do. This will run the behavior tree when we overlap with it. Then next, we're going to make a new blueprint class again, but this time we're going to make a basic object. These tasks are going to be normal basic U objects that are just going to hold some very basic rudimentary information and maybe a little bit of code. The reason that we're doing this as objects is because it's easy to pass around references to objects and only have like one instance of it existing. So if we then added that from that reference and any other place, because it's an actual object and we're not passing around like copies of values or anything, everything else in our system will immediately be able to reflect that, which is nice. We'll make a object, call that quest task or something like that. And this is going to be, if you've never worked with basic U objects, a little tricky because it doesn't have things like a begin play. It doesn't have a built-in tick function. It really doesn't have anything that it comes with. It's very bare, but that's kind of the point. That means that it also doesn't have a lot of overhead. My other quest system is almost entirely based on working off of writing custom basic U objects, which does make things a lot more complicated. We're not going to lean on that as much in this version. So we're just going to add a handful of basic variables for this. The first one is going to be whether or not our task was finished, because that's mostly what we're going to query this for, whether or not our task is finished, and effectively deciding to do whatever based on that. We also want to give it a name to mostly display things, and that's going to be a text variable, not a name variable. Easy mistake to make. This one we're going to set instance editable, and then also coming over to the details panel, we're going to expose it on spawn so that we can set it immediately when we create this object. And then lastly, we're going to make a task ID. And this is mostly to identify. You could identify it by the name, but that is a string compare, which is relatively slow, and we're potentially going to be looping over quite a lot of these in some cases. So having something easier to identify them by is quite good. So we're going to identify them with a GUID, which will also set to instance editable and exposing on spawn. GUIDs are simply global unique identifier variables. So that's just a little bit of code, a couple of numbers that are very easy and cheap to compare and look at, that the engine can generate for you to make sure that there's no like doubles. That would be the other downside of if we're using a name to compare certain tasks to each other. If two tasks have the same name, that could result in some kind of conflict. With GUIDs, you don't end up with that issue. And lastly, we add an event dispatcher for the objective being finished. Maybe later down the line, toward the end of the series, we'll also add an objective updated, because I think we're going to want to have potential objectives that can be partially finished, like find 10 of this type of item. But for now, we're only going to worry about objectives that are either finished or unfinished. So with all that, we can make a function and call that something like finish objective or finish task or whatever you want to call it. I like calling these objectives because state trees have tasks, and I want to make like explicitly clear that these are two separate things. So as a matter of fact, let's call this quest objective as well for the class name, just so that it's entirely clear when I'm talking about an objective and when I'm talking about a state tree task. So when we finish the objective, for now, again, we're just going to set our task finished to being true. And then we call out our objective finished. But before we do that, we actually want to add a input to it. We're going to be adding an input of the type quest objective, because we want to send through a reference to itself, to whatever is listening out for finished objectives. We're going to have other things listening out for every objective. When they're finished, they're going to do something. And for that, they might need to know which objective just finished. So what we do is we add that as a input here. Call that something like just objective. And then when we call this out, we simply provide in a reference to self. And that's the entire setup for the quest objective object. And with that, we can now start going back into our quest tree itself. We're going to go up to making a new task, and for that we're going to make a STT for state tree task and create basic objective. Let's create that, and immediately I'm going to go into the class settings here, and we're going to go to advanced and set this to be an abstract class. That means that we can make other child classes off of this in the future, which we will do in a moment. But we can't actually use it in our state tree, because this isn't going to be exactly usable in any sense of the word. This is just going to be the basic setup of creating the objects we just set up, and then handling what that object is going to like be bound to, all that kind of stuff we'll do in other child classes of this, such as going to a location, finding a certain item, killing a certain enemy. Those are all going to be their own types of tasks. So we'll override enter state here, and what we're going to do there is we will construct a object from class, and we'll just make this a quest objective, which is going to ask us to put in a name and a task ID. So we're going to promote both of those to being variables, and we'll set both of those variables to be instance editable. Then the output of this is going to be promoted to a variable as well. We'll call this the quest objective. And for this one, we can set it to instance editable if we want to, but it's more important that we go into the category for it and mark it as being a output category. That way, other things in our state tree tasks can reference this object that we just created. And that's the basic setup for just the base creation of these objects. Now, if we go back into our state tree right here, and we just add in a quick like child state, that'll be like objectives 1. You will notice if I go into my tasks, I don't have the task I just created as an option. But if I go into new tasks, I can make a child class off of the STT create basic objective. That's what that abstract class tick box does. So let's make a chart of that again, and we'll create a location objective. Something quite simple. Here we will override the enter state, and you might need to right click this and add a call to the parent function, because that is going to run this. Otherwise it'll probably not run it. So you connect that up, and then we set up a variable here, and that will be our location trigger, and we'll make that of type trigger base, because every other like trigger actor that we can create in the engine is going to be inheriting of this, so we can make it a trigger box or any other type of trigger that the engine might have. The category for that is going to be input, because we want it to be exposed, and it also needs to be required to fill in, because if we make this objective without anything to trigger it, there's no use in that objective existing. So we want to force us as the user to input this. That's why we mark it as input. Let's pull that in. And then we will bind on overlap. So bind event to on actor begin overlap. And pulling off of this event, we can just make a custom event. It'll have the corresponding proper parameters to go with it. For now, we're just going to cast the other actor to a third person character, because again, that's just the easiest way to check that. You could technically use the isA with a soft reference to the class. That is a new function in Unreal 5.5, I believe, that prevents it from actually like hard referencing and loading that class in. So that's probably a better practice to like get into. It doesn't really matter here because we're referencing the player character anyway, and you might want to check whether or not it is the character that actually has been given this quest as well. But it doesn't hurt to like get into the habit of doing this. So if the trigger that we're looking out for just got overlapped by a third person character, then we get our quest task, or quest objective rather, which is the one that we created in here, because remember, this is a child class of this one, so any variables that we make here, even though they're not visible through here, if you go into class defaults, you can see that they do exist still here, and you can just get them through normal like getting of variables like you would in any other blueprint as well. And we finish the corresponding objective here. So that's a setup for going to a certain location. Now, let's also print a string when that happens, just so that you can actually see something on screen happening, because we don't have anything else happening, obviously, at the moment. But I want to put this into the world and show you that stuff is actually happening. So when we do that, we go in here into tasks, and we can add a location objective now. So this needs in a trigger. We can give it a name and an ID. We'll ignore that for the time being. How do we provide in the trigger? Well, we do that through making a parameter for it. So we can rename this to location 1. And then we make it of type trigger base. And now, because this is a global parameter that is accessible by anything in the state tree, we can go into our trigger location, parameters, and we can reference that. So now, this objective is looking out for whatever we put into the parameter here. And we can fill that out on a per instance basis in the world. That way, you can technically use this same quest tree even with different location triggers on different actor quest givers in the world, if you really wanted to. So let's add a trigger box. So trigger capsule, trigger sphere, technically trigger volume as well, will all work. We're just going to go for a basic trigger box, and I'm going to replicate the thing that we did in the example, which is just going up to like this cylinder here. And then I'll pull in one of these quest giver blueprints that we made. And there we can go over into its state tree, set up the state tree to use quest 1, and you can see that it now makes available the parameters. So we can say, hey, parameter number 1 is going to be this trigger box, which means if we walk over here, nothing happens because we haven't gotten the quest yet. But if we activate the quest by overlapping with this thing and then overlap, you can see we print out hello, meaning that the quest was activated, started listening out for us to overlap with this, and when we did overlap with it, it prints out hello. Now, technically, it will print that out every single time we overlap with it, because it's still listening out for that. That's generally not really a problem because all that it's doing is just setting task finished, which was already set to true again. So that's setting up the basics of using tasks. Now you can just do this a bunch of times. So we can add in a second task immediately and then go in here. And when we finish this objective, we also finish the task. And when this is finished, we can add a transition to go from task 1 to the next state. And here we can then add in something else entirely. This is how you can set things up if you want to do things one step at a time. That's not quite how we're going to do things. We'll do that in the next video where we set up a task manager to manage any amount of tasks that we want at once on one state. So you can just do that with this one task at a time still. But that way you can also add 3, 4, 5, 6 tasks at the same time that you can complete in any order before moving on to the next set of tasks. Or again, objectives. I'm going to use those terms interchangeably a lot. Long story short, we can have a handful of these objectives that we created that all need to be finished before moving on to the next set. We'll do that next time. For now, we have our basic going to a location and something happens working. Now that we can set up a single objective and kind of have the bare bones basic layout of what a quest can be, maybe let's look into making a system that can handle multiple objectives in one state in our state tree. So the way that we're going to do that is opening up our quest here. We already can make these location objectives now. So let's actually just duplicate this one and make in our details panel for the asset also a duplicate of this one, which you can't do. You actually have to manually add a new one because it's a little clunky that way sometimes. Add location number 2 and make that type trigger base as well. And then in our location trigger, we're going to get our parameter location 2, so that's going to be looking out for that. Now, how do we set something up that only finishes this state and moves on to the next state when both of these objectives are complete? Because if we just go in to here and we simply finish task, that will finish the entire state when any of the tasks are done, which is not what we want. So we want to add a new third task here that's going to be managing all of the objectives above it. So let's go make a new task, state tree blueprint base, and we'll call it STT objective manager, which I probably horribly misspelled, but we're not going to really pay attention to that. Enter state. When this state gets entered, it's going to gather up all the objectives that it cares about and then bind to whenever they are completed. Whenever one is completed, we're going to be checking, hey, are all of them completed? And if all of them are completed, then we'll finish this state. So for that, we're going to need a variable for our objectives, of course. So objectives, which will be of our type quest objective. And we're going to make that into an array because, of course, we're going to be looking at multiple objectives here. So on enter state, we'll do a for each loop over all of these quest objectives, where we will assign to objective finished in the loop body for each and every one of these states. Now, whenever one of these finishes, as I said, we need to check whether or not all of them are finished. So let's make a function for that, and we'll call that check all tasks completed or finished, whatever you want to call it, really. And that's going to have a singular output of all completed of type Boolean. And this is a fairly straightforward function as well. So all that this is going to do is it's going to, again, get our objectives. It's going to for each loop over those objectives. And it's simply going to get the task finished, because that's just a variable that that object holds. And this is all that we really need to know. So we'll just go over all of these. And if it finds any that isn't finished yet, we're going to return with a value of false. That's going to stop the for each loop, and it's going to give us the information that, hey, there's at least one objective that isn't finished yet, so the quest, or at least this part of it, still is ongoing. If it ever reaches the end of this loop, that means that it's never found a task that is not finished, which means that all the tasks are finished. So we'll return a node with the bool set to be true. Now that we have that, whenever we finish any of these tasks, this runs and we simply check, hey, Are all of them completed? If all of them are completed, we can then finish this task. Going back to the variables for the inputs here, or the objectives, it's going to be an input, so it's going to be required to be filled out, because this whole thing doesn't make sense if we don't actually like put anything into it. So with that setup, we can go back into our quest, objectives 1, let's call this state under here objective 2, by the way, and say we have these two location objectives that we create and bind, but then we have our objective manager on this state as well. It is good to put this at the bottom because I am pretty sure that it does execute these in order. So you want to create these objective objects first, which have their like outputs, and we're going to be using those outputs as inputs for this. So in our objectives array inside of our objective manager, what we can do is we can then just say, hey, look out for this quest objective and look out for this quest objective. You can also rename these if you want to be like a little bit more clear about what they are. So just right click, rename first location, and right click, rename second location. So now it will look out for both of these objectives to be completed and then move on to whatever our transition says it should do next. So in this case it would be next state, so it would go over to this one. And when this one is completed, it will go back to root. If you have an objective state that only has one objective that needs to be completed, you very much can also just add one of these managers and only add in one reference to one objective. That's entirely possible as well. If you prefer, you could also update this location objective to have a bool on it where you can say like is single objective, and when this is finished, if it is a single objective, you just finish task as well. That way, if you have a singular objective in any given state, you don't need to also add a manager for it, because if there's only one thing, there's no real managing to be done. If this is a single objective, just make it instance editable. Default value for that is going to be false, but now we don't need this object manager anymore, so we can delete this and we can just set this, hey, this is a single objective, don't need to worry about any like managing stuff, this will just take care of itself. And then when the transition happens for this one, we're going to go maybe like 3 succeeded, so that actually finishes off the quest. Now, since that is a fairly like basic setup of how these things work, I want to do a couple of other things in this video as well that don't really like have room for their own videos, and that is going back into our quest giver. I want to make sure like of one important thing. So BP quest giver. Right now, when we overlap with this thing, it's always going to start logic, which is kind of okay, but it also might be a little bit of an issue. It might be a little bit problematic. It might be whatever. What you can do, you can get a state tree. We can check if it is running at this time, just so that if we already are running it, we don't really want to check on anything like at all, really. So only if it is not already running do we start logic. If it is already running, we for now just print a string quest in progress. There's a little something else that we can do, and that is this has a delegate or an event dispatcher that we can bind to. So let's say assign on state tree status run changed. You can put those words in the right order yourself. It is on state tree run status changed. Which provides you in with whatever new run status it has. So this is an enum, so let's put in a switch node for those. And here we can check, okay, so when we start our logic, we now bind to this, and we can check, okay, when it stops running, it's obviously not going to be in running anymore. But we can check if we failed the quest, or if we succeeded the quest, or if the quest was just stopped for any other reason, or if it is now unset. Which realistically, it's probably never going to be this last one, but we can check for this quest to have succeeded. And here we can then do something to like reward the player. So for now, we'll just do a reward as a print string. And as you can see, it also has a fail pin. So you could use it to, for instance, say, hey, if you fail a certain quest, maybe you get punished. It's a little bit tricky because the way that I have things set up later down the line for dealing with saving and loading quest progress, Sometimes it also does use the field as like a quick failsafe to exit out of a quest that it started but shouldn't have started. So keep that in mind, but that is something that maybe you can do some stuff with if you really wanted to. Now, the other thing that I want to do is I want to make something that just starts the next quest when this quest is finished, because that's also relatively easy. So we can go into our quest tree here and make a new blueprint-based task, STT next quest. So we can go into our state tree here and make a new blueprint base here, and we'll call it STT Quest Manager. This is going to do some other stuff aside from just running the next quest as well. But for now, that's all that we're going to be programming into it. So let's save that. And this is relatively easy. Again, this blueprint is going to get built out quite a lot when we get into the save and like displaying systems for everything. But for now, all we need is a exit state, which is going to have a variable of the quest giver for next quest. So let's call next quest actor, which is going to be type BP quest giver. And whenever we exit this state, because this is going to be on the root state of our quest, so whenever we exit this state, that means that we've finished this quest, we simply do this as a validated get. So only if this is actually a valid reference at all are we going to do this. We'll simply start this new quest, for which we do need to go back into the quest giver real quick and change this from just being BP overlap into being its own like custom event. So we'll call this something like start quest, which will then run on overlap as well. So start quest like this. But now we can explicitly call it from other places as well. So going back into our quest manager, we can now start that quest. So this is relatively easy, relatively straightforward. But if we go back into our root, we add a task for our quest manager. We make sure that this next quest is an exposed variable. It doesn't need to be an input because it's not required to give it in. But this way we can set our next quest actor if we really need to. And if we do want to do that, what we're going to do is we add that as a parameter, right? So we do this as a BP quest giver type, object reference, call this next quest, and then we can bind to that parameter in here. So now when we finish this quest as a whole, it's going to look at this next quest. If it is valid, it's going to tell that next quest giver to start its quest up. So let's say we copy this over. We put it somewhere out of reach because obviously this has an overlap at the moment, which we don't want to accidentally trigger. And we say that it is going to be the same quest actually that we had before, but this one is going to use different trigger boxes. So that's entirely something that you can do. You can use the same quest tree to just bind to different locations that you want to visit. So let's say that we have two trigger boxes here for the first quest. So we go quest number 1, location, and location 2. And then the next quest that we trigger will be this one. And then we have 2 more trigger boxes, which let's just set those up over here somewhere like that. I'm actually going to select all of them and make sure that hidden in game is turned off for them, just so that we can see them. So actor hidden in game is turned off. And let's put in back that print string of quest objective. We'll just print its name. Well, actually we have the get name as well, right? Yeah, so let's print its name when we like actually finish an objective, which means that we do need to like go in and give some names to the objectives here. That's the downside of reusing these quest trees, is that the names and the IDs are actually like baked into the tree itself, so those won't be unique between different instances of using the same tree. So it's a very limited use case, but it is something that is technically possible and like allowed to do. So walk to location 2, and then this one will be walk to location. I think this is just bound to location 1 again. Yeah. So now you can see if I overlap with these, they don't do anything because nothing is bound to them yet. If I go unlock this first quest and go back, still nothing will happen because they are not active as a quest. However, these will say walk to location 2 and walk to location 1. And now that I've done that, I think I have to do this one again. Yeah, walk to location, so we get a reward. We finished the quest, right? And now that we finished that quest, the next one automatically has opened itself up, and now these will actually do stuff where I will be able to finish this quest as well. So just with that, we basically have a functional quest system. There's a lot of work that needs to be done to make this user-friendly, like we aren't able to save any of this data yet, or keep any progress, or show any progress, or any of that. But the bare bones basics of the functionality at this point exist, and you can start designing your quests. But this is all kind of difficult to work with because we can't actually see what we're doing at all. So I think next time, before we dive into anything else, we're going to set up a widget that we can just use to like look at what our current quests are and what the progress of those quests looks like. Functionally, we have a quest system, but functionally that doesn't matter until we can actually display our current quest. So I think it's high time that we look into setting up some widgets that can display our current quests and our progress in those quests. This isn't going to be too complicated, but it's going to require quite a bit of setup, so let's dive right into it. As per usual, you can get the project files to either this part or the entire completed project for the entire series down below in the description for patrons and YouTube members. So first we need a place that we're going to be storing our quest progress in. And you can do that just on your character itself. That is entirely a valid way to do it. You can do it on a game instance if you prefer. It kind of depends on if you're going to be moving between levels a lot. Doing it in a game instance, which is persistent, might be a little bit easier to deal with. So I'm going to set it up in a game instance, but if in your case you prefer doing it on like the Blueprint character or maybe anywhere else that might suit you a little bit better, do feel free to fill it in however you like. But for us, we're going to do it in the game instance. We look for more actors and then we go for game instance, and we'll call that something like BP Quest GI. Do be sure to go up into your project settings though, look for game instance and change your game instance class to our BP game instance that we just made. So now that we have that, we can make an array of all the quests that we're going to work with. But for that, we're going to need to make the type of variable that this array is going to be first. And that is going to be a custom struct. So let's go in here into our blueprint and make our structure. We'll call this quests task status display. We're specifically calling this one display because we're going to be making a version of this as well that is more geared toward saving the data. This is only meant to display, so it's going to be using things like text. When we end up saving this data, we're going to be saving it as a more machine-friendly format instead of a human-friendly format. So for now, let's open this up. And this is going to have a couple of different things. First and foremost, obviously, it's going to have the quest name, because we need to be able to display what name this quest has. It's going to be a text. Then I also like to add in the quest ID, which is going to be a GUID. Because as I mentioned in the previous video, you can iterate over all of the quests in progress and just check their name. If you have any quest that has the same name, that might lead to results that are less than ideal. It's also just slower because you're not even just checking two strings against each other, which in and of itself is slow. You're also using a text, which needs to look up the purple string based on your language settings. And while that doesn't make it super slow compared to a normal string compare, it's yet another thing that it needs to do. GUIDs are just comparing two numbers and that's it. So it's nice to have that for comparison reasons. And then we have our task status, and that's going to be our quest objective type that we made. That's the basic object that we made in the very first video. Let's actually call this objective status as well, because I did promise you to be a little bit more descriptive with the difference between tasks and objectives, and this is going to be an array. Because every single quest is going to potentially have a variable near endless amount of different tasks to it. So this is going to be the structure that's going to hold our entire quest progress. So going back into our game instance for that, we can now make our quest progress. This is going to hold all the quests that are currently active with how much progress they have. If a quest is finished, we're going to remove it from this array as well. You don't necessarily need to. You can just keep it in there if you really want to, but the array will start like becoming longer and longer and longer for something that you're not actually interacting with anymore, which is going to make looping over it a lot more intensive. So we're going to be removing it after we finish any given quest. And this is going to be of type quest task status display, and we're going to make that into an array. So now, whenever we create a new quest, we're going to be adding it to this, and then when we ever create a new task in that quest, we're going to find the quest that it belongs to and add it to the array for that specific quest. So we need to go back into some blueprints that we already worked in to figure this out. So let's just open up our quest tree here, and the very first thing is in our root we have that quest manager that we made kind of as an aside last time. We're going to be adding a lot more code to it now, because when we enter this state, we're going to create an entry within that array that we just made. So let's add the enter state here, and we're going to get our game instance, and we will cast that to our BP game instance. And for ease of future use, we're going to just promote this to a variable so that we can easily access it from a bunch of different places in our blueprint graph, because we're going to be accessing this quite a lot. And with that, we will get our quest progress array. Now, you might initially just want to add to this, and you can split the structure pin, provide in the quest name and the quest ID, and just leave the objective status as blank. That is entirely a valid way to do things for now, but what if you make this quest from a save file where you already have a handful of these objectives completed? So we're going to set this up in a way that's going to make setting up the save files later down the line a lot easier, because it won't need a bunch of reworks. But it's going to make this slightly more complex for the time being, because what we're going to do is we're going to for each loop over our array of current progress. We'll split the structure pin, and we're going to be comparing whether or not the quest ID is equal to the quest ID that we're going to give this quest itself, for which we need to promote this to a variable. So let's call this quest ID and expose that so that we can add it in the actual quest tree itself in a moment. And we find that it already exists in this array. We don't want to add it a second time. And we can't simply check whether or not the exact struct matches, because if it had like different completion data in it, it doesn't technically match the entire struct. So we need to loop over it and check, hey, is this quest ID an ID that we're already like in progress in any way, shape or form? If it is, we're going to make a new variable here for quest already exists, and we'll just set that to being true. Then once we've looped over the entire thing to make sure that it doesn't exist anywhere in the already existing array, we'll simply check, hey, did we, while looping over that entire thing, find if this quest already exists? Because if it does, we can just simply do nothing, or we can finish this task, because obviously then we don't want to actually like start the quest like at all. For now, we're just going to do nothing, and only if this is false, so if it doesn't already have this quest, are we going to get our quest progress, and then we will add a new quest to that array. And I'm going to just add a rerouting node here real quick to make things look a little less messy. So let's split the structure pin now. We'll put in the quest ID that we made before here that we were checking against, and then we'll also promote this quest name to a variable. I like to put this as an input though, so quest name, because this is potentially going to be used in other tasks as well. So that's indeed going to be a text, and we'll call this a input category. So it's going to be required to give this quest a name value, just because we're going to be binding this to a parameter, because other things are also going to be using that parameter. The objective status is going to be entirely blank, because obviously we only need to create this entry for this quest in the array. Then we're going to be finding it again in a moment in the actual objective manager, and that is going to be adding things to this array instead. So this is the adding part. of showing our quests. So let's actually put that up top because that is a state enter. On state exit, we at this point just check, hey, do we have a next quest to start? If so, start it. But now we also need to go back in, find this array, find the corresponding quest, and remove it again. Because if this quest is finished, we don't want it to be in that array anymore. So once again, we get our game instance and we get our quest progress just the same. So get progress. We'll put this to the side for now. And we will for each loop over that. And we'll just kind of do the same thing. We'll split this structure pin, we'll get our quest ID, and we'll just check every quest ID in this array against the quest ID for this specific quest. Put the other code to the side a little bit more even. And if it's found it, which it eventually will, because it will be in this array, that's what this code makes sure of. When it finds that quest ID, it's going to remove it from this array. So we remove a specific index, and that's going to be the array index from our for each loop. Now, if you want to be like super sure about this, not like needlessly looping over a long array, you can actually make this a for each loop with break instead. And then after you've removed it, you can break out of it so that it doesn't loop over the rest of the array needlessly because you've already found what you're looking for. So let's actually just do that. Split structure pin. We're going to be putting this into there, and that lets us delete the original for each loop. Put in a couple of like reroute nodes to make it look a little bit less messy. This is with C++ just kind of is nice because you don't have these lines all over the place crossing over each other, but hey. And that's what we're going to be doing on state exit instead. And once all that is complete, we can do the code that we did before, which starts next quest, if at all relevant. So that's the quest manager side of things. But now I want to go into the objective manager and also make that add everything that it needs to add. So going back into our tree here, picking one of our objectives and just finding the objective manager to go edit that. When we enter this, we're going to need to do a little bit more again. So here we are already looping over the objectives and we're binding them. But after that, what we need to do is we need to get game instance again. So we can probably do the get game instance and setting that to a variable before the for each loop. So we're not actually getting that over and over again because that's going to remain the same. So get game instance, cast it to our BP game instance. You could make a blueprint function library function to just get this a little bit easier so that you don't have to like repeat doing this every single time. But for now, we'll just like promote this to a variable. So now that we have that game instance, after we complete this first for each loop, so after we've done like all this binding, what we're going to do is we're going to do another for each loop. So we'll get our BP game instance and then get that progress array that we made, and we're going to be for each looping over that. So for each loop here. I guess this could be a for each loop with break again, just to save a couple of loops if at all possible. And here we're going to, again, split structure pin, and we'll check if our quest ID is equal to, and we'll promote that to a variable again. So quest ID. Make sure to mark that as category input again, because this is super important to actually provide in. And if we have found that, we're going to move on with this rest of the code, where we're going to get all of our objectives, and we're going to for each loop over all those objectives, and add them into this array that we have on our other array. So we get this array and we add to it in this other for each loop the object that we're working with here. And that's really all there is to it. So what this is going to do is it's going to try to find the quest corresponding to our quest ID. Once it's found that, it's just going to get all the objects that this manager manages and add them to the quest progress itself. Now, because these are all objects, quickly going in here during the editing, instead of using this array and adding to it directly, that doesn't quite work because these are technically copies of whatever is in this array. What you need to do is you need to pull off of this and get a reference to a specific index, which you can get through this array index instead. Then if we break that reference, and we add to this array in this reference instead, everything will work because it'll actually be adding it to the array in here instead of a copied value that the for each loop uses. whenever any of these objects like update themselves when they have been completed, this array is going to immediately be able to like reflect that and have all that up-to-date information. This is why we're doing it object-based instead of making a bunch of structs, because then you need to go like all over the place and update every struct when everything updates, and it's just a mess. So that's what these like basic U objects really come in handy for. And then once that is completed, I guess we can break out of this for each loop, because once we found the quest, there's only going to be one of this quest in that array. We ensured that before. So now we'll have a proper list of all the currently active quests with their objectives. So let's make a widget for that, shall we? That's going to be the easy part of this. So we can just go user interface, make a widget blueprint. I'll call this WBB quest entry. In that, I'm going to put a size box to hold everything. I'm going to real quick set this to desired, just so that we can see how big everything actually is. Personally, I like to then just go in with override like 500. Your mileage may vary as to like what size you want this to be, of course. In there, we add in our vertical box. We'll be stacking a couple of things on top of each other. The first thing will be a text. That's going to be the name of the quest. And then I will put in a horizontal box below that, which is going to have a spacer and another vertical box. So here we can see if we give this spacer a bit of padding to like the right, let's say 50 units, this vertical box is going to be offset a little bit, so we'll be able to add text to this. It'll be offset and it'll look a little bit nicer that way. Now, this vertical box is going to need to be a variable as well, because we're going to be dynamically adding to it. And that's about everything we have going for us right here. So let's go into the event graph for this and set up what we need to set up. On event construct, of course, the first thing that we need to do is we need to make sure that this is also set to variable, the quest name, because we're going to be setting that dynamically as well, obviously. We set the text for it to being whatever it needs to be. So for this, we're going to take in a variable, and that's going to be the quest progress. And it's going to be of type quest task status display, the structure that we made for this. This one was set to instance editable and also expose it on spawn. When we create one of these, we want to just give in all of the data to display for this quest, which will, in fact, include its name. So we'll use that to populate the name here. Then we'll have this array of its objectives. So we can just for each loop over those. And for each one of the objectives, we will construct a object from class, and what we're going to be constructing will be a text. So this is one of the things that you can create within the widget blueprints. But if you just try to create a widget, the like base objects for it, like text and that kind of stuff, like rich text block, it's another one that we see here, you can't actually create with the create widget node. So you need to use the construct object node, where you can construct a text. I'll show you real quick just to prove that with create widgets. If I try to find the text, it's not going to let me. But doing this is exactly the same as creating one of these text blocks just from within the UI. So we can use the set text on this as well. And we're going to be getting from the array element, get the name for the objective. And then I also like to set the color and opacity for these. So if it's already finished, it'll be a little bit grayed out. We can use a select node for that. We'll get the array element again and get whether or not the task is finished, because again, it's just an array of objects, so we can very easily get the currently most up-to-date value for that. Put that into the index for the select node, and then we can just make a slate color for if it is not finished, which is in this case, we're just going to make that white. And if it is finished, we're going to make that like more of a dull gray. And then at the very end here, we'll get our vertical box and add a child to it. And the child that we're going to be adding will be this. Now, I want to point out one thing. In the previous quest series that I did, which again is a bit more complex in a lot of ways, we made everything so that it would dynamically show whenever I completed an objective. It would update the UI for it as well. This is not going to do that. What this is going to do is it's going to create a UI for you that shows you the current state as you open it. So this would be something that you put in like a pause menu, because while you're in that pause menu, you're never going to be finishing quests. So this doesn't need to update in real time. If you want to update something in real time, it's going to get a little bit more complex, because now this widget itself is going to need to also like assign to objective finished and then update itself. You can do that. We're not gonna go through that right now, because realistically you're gonna put this in like a pause menu in some kind of like quest book tab anyway. Now we have something that can show a quest with all of its sub-objectives fairly easily. So now all we need to do is make another widget that instances a bunch of these based on how many quests we currently have active. So make another user interface, widget blueprints. Going to call that WBP quest book, and this one is going to be even more simple, so don't worry about it. What we're going to do is, because this is going to be one that we directly add to the viewport, I'm going to start with a canvas panel, and within that I'm going to put a border, and I'm going to just set its anchors to be screen filled, and the offset will be 0, 0 for everything, and then we'll set the offset left to like 200. From the right also it's going to be 200, and then from the top and the bottom it's going to be like 500, or maybe maybe a little bit less. Maybe switch that around actually. Maybe make this 500 and I'll make these 200. Pretty good. So left and right are going to be higher numbers, and then top and bottom are going to be like slightly slower numbers. So we get this kind of square. Maybe even make this like 350 instead, so that's a little bit wider. You can do whatever you want with this. This is of course just a quick little like example widget. I like to set the brush color itself to being black with then an alpha of about 50%. And then within this, we're going to be adding a vertical box. And then just to be sure, I also am going to add within a vertical box a scroll box, because we're going to be adding things to the point where maybe they don't all fit within this one screen. So this scroll box is what we're going to be setting to is a variable. On event construct, we can pull in our scroll box, start out with clearing the children just in case anything was already in there, because we're going to be adding and removing this to the screen, and every time we add it back to the screen, it'll run event construct. So if you don't do this, it'll start adding the same quests over and over and over. From here, we very simply do a get game instance without having it pulled off of this node like I was just doing there. We do get game instance, we cast that to the BP game instance, we get our progress array, we for each loop over that progress array, and for each one of those we're gonna get our scroll box and we're gonna add a child to it. The child that we'll add to it will be a create widgets, and that'll be our quest viewer widget that we just made, so our quest entry, which needs a quest progress struct, but wouldn't you know it, we do have that from our for each loop. And then we just provide that into the add child, and that's pretty much all there is to it. So now on our third person character, we can just make one on begin play and then just make a key to like make it appear and disappear. As easy as that. So let's make a begin play event, create a widget, which is going to be our quest book. We'll promote it to a variable, call that quest book, and then we'll make a debug key on queue. Obviously, if you make an actual game, this would be an input action, but I'm not going to set up an entire input action for this right now. When we press this, we simply flip-flop between adding it to the viewport on A, and then remove from parent on B. So now let's go back into our state tree and actually start setting up the proper values with all the names and stuff, because we do need to do that, obviously. The root itself is going to need to have a quest name that it takes in. So let's make that a parameter here. Let's call that, let's make it a text and rename that to quest name. Your first quest. In the quest manager, we can just simply reference that to there. Now, these are all going to need quest and task IDs now as well. The task IDs aren't really relevant yet, but the quest ID will become relevant. So you can put this in as a parameter, or maybe even host this on like the quest giver actor blueprint. But if you haven't generated this yet, you just press this little drop-down menu, you generate, and it generates a unique ID for you, which you can then access from anywhere in here. So go into our objective manager for this. Quest ID is going to be our quest manager quest ID for this one as well. I guess we haven't set up the single objectives to like work with this yet. So that's a little bit of a downside to we have the single objectives set up. I personally just think that using a quest manager with a single objective is going to be easier than making the single objectives also like report themselves back to like the displaying and saving systems as well. But if you wanted to, instead of doing all that we did in the quest manager, you can very much do that in the create basic quest objective and then just like add itself to this and make this one take in the quest ID. The annoying part about that is now you have to provide in that quest ID for every single one of your objectives, and there's no real good way to automate that. So I personally prefer putting that in the manager because you're only going to have one manager per state. So changing this around now to replacing this with or adding in rather, a manager and not using this is single objective and instead just doing it like this way in general is going to be a bit easier and less of a headache. So I'm going to personally go back in and get rid of the single objective setup because I think it's kind of not a great way to do things to begin with. But now we do have a quest ID. So, and now you'll see, I have no quests. I run over this one, and now I have my first quest, which has walk to location and walk to location 2. So again, if I just do this while this thing is up, it's not going to update, but if I remove it and re-add it, you can see it's now marked walk to location as being finished. Now, if I do this other one, you see, hey, we now have our new objectives unlocked, which again is just walk to location number 1. Now that that quest is completed, it'll be gone from the list and it says your first quest again, because it is a quest with the exact same name. Again, we have this entire like quest set up twice. Quest number 2 used the same tree. At this point, you can see why that's a very niche use case. I wanted to show that you could do that, but you probably shouldn't. So we're just going to copy over this quest instead, and we're going to do quest number 2. I guess you can set the quest name itself as a parameter as well, and you could technically make every single task name a parameter and reuse quests in that way if you wanted to. I think it's just easier to do all that within the trees, but it's flexible enough to the point where you can set it up however you personally like. So let's make it so that this second quest is the second set of objectives maybe. So instead of doing this going to the next state, on transition what we'll do is we will complete this tree, so tree success. And that's then going to start this one, which is going to be just walk to location. And we'll call this again. And the name for this will be your second quest. So we'll see, nothing, your first quests, we'll do the first quests, we get a reward, and now we have your second quest, walk to location, and once we complete that, apparently that's the wrong one, we need to do it at that one, no, it's bound to one of these then maybe, surely one of these, it's bound to this one, okay. So we have a displaying method now for our quests, our progress, and everything of the sort. The one thing that we don't yet have is the ability to save between play sessions, because if I now go back in again, I can restart this quest, because we haven't done this quest yet, we don't have anything saved. So next time what we're going to be doing is we're going to use all of this setup that we have now, and we're going to do something very similar to like gathering up all that data for displaying, but instead we're going to be gathering up slightly different, slightly more machine-friendly data to save it. And then of course also to load it. It's time to be able to save the progress we make in our quests, because you're not going to play an entire game with all the quests that have been made in one sitting, right? Or even if you are, you want to be able to save that stuff. So let's make a save system to save the progress we make in our quests. Now, essentially we're going to need to keep track of two things for our save system. Number one is we already have our game instance with the current progress of all of our actively started quests. So we can just make a slight variation on this data type that's a little bit more save friendly. Because this at the moment, if we like just get something and we split this structure bin, uses objects. And we can't save objects because these are places in memory, and whenever we load the game again in the future, these are going to be in a different place in memory. So we need to make a struct that saves the information that's also in this object, and then we also probably like don't need to save the quest name and that kind of stuff. So we're going to be making a structure that is a little bit more friendly toward that. And then we also need to save all the quests that we have finished, because that's probably going to be relevant information to finish as well. So the very first thing is we're going to be adding a new array here of finished quests in our game instance, and that's going to be just a state tree object reference, and we'll make that into an array. And here, quite simply, we have our quest manager already for our state tree. When we finish a quest, we already remove it from our active quests in progress. We'll just simply also get our finished quests and add this quest to that. So what we'll do is we'll simply add. We can add unique to make sure that it doesn't add them twice, just to be sure. And we'll just put this in between here, and we'll promote this to a variable quest asset. Now this is kind of annoying, and this is a thing that maybe if you're watching this in the future is possible to do, but state tree tasks don't seem to have a good way of getting the state tree assets that they're currently executing on. So we can't just like get state tree or something like that. You can get states, but that's something else entirely. So you can't really do that too easily. So what we're going to do is we're just going to make that into a variable, expose it, and that way if we go back into our quests, we can just go into the root here, we have our quest manager, and we can just say, hey, this is the quest that we're working with. It's annoying that we have to set it up this way. Hopefully in the future, if you're watching this and it's like Unreal 5.17 or something, that'll be a feature that just states can request whatever state tree they're on. As of right now, that doesn't seem to be possible. So yeah, that's just going to add itself to the finished quests array on our game instance. And that's really all that we need to do on this side for the time being. So on the game instance, we're going to need to set up the saving and loading functions. So let's make a custom event for save game and a custom event for load game as well. We'll be filling those out both shortly. And I'm also going to add the onInitialize event, which is here somewhere surely, or just called init. Because when we initialize the game instance, what I want to do immediately is I want to just like create a save game object, and for that we're going to need to make a save game class. So let's make one of those. New blueprint, save game, and we'll call this SG Quest. We're going to leave that alone for a moment. We'll come back to that in literally like a couple of seconds, but before I forget, we'll just put that save game quest class into the create save object, and we'll save that out as a variable on our game instance. So this will be our quest save object. Now this is going to need to have a couple of things, so let's open it back up again. We are going to make a variable for all of the finished quests that we've done. So let's call that finished quests. And again, you might be wondering, how are we going to even like do any of this? Because you can't save those assets either, because those assets are, again, going to be object references, and you can't save object references. But since they're assets, they're actually pretty easy to save. You can just save them as a string. And we're going to save them as an array, because of course there's going to be a bunch of them. But then, saving the current quests in progress, we can't just put that into a string. Well, we technically could, but you don't want to. So we're going to make a structure specifically for that as well, just like we did in the last video. Let's go into our blueprint here and make a structure, and we'll call that quest task status save. This is why we called the other one display, because this is going to be one that's very similar to it, but different in some important ways. This is going to be storing the quest ID, just like the other one as well, which is going to be a GUID. But then it's going to be storing an array of another structure that we still need to make as well. So let's go back in again and make a structure. And this one we will call task status save. And this is going to have inside of it the task ID, which to nobody's surprise is going to be a GUID as well. And then it's also going to have the task status, which is going to be a bool. We might expand this later on to also include like a float for the percentage of how far along you are in some task. If a task has like sub-steps, like collect X amount of a certain item or defeat X amount of enemies or whatever. For now, I'm going to keep this simple as it is. So we now have this task status save, so we can go back to our quest status save and add that in as a variable as well. So this will be the tasks, just tasks, that'll be good enough. And that'll be of type task status save. I'm going to make that an array because a quest is going to have multiple tasks that it needs to save out. With all that set up, we can go back into our save game blueprint here and make our quests in progress array, which is going to be of the type quest task status save. So now let's go ahead and populate both of these arrays. You can go back into your blueprint game instance and do that all from here. Personally, what I like to do is I like all the objects that need to like have their data saved in any way, shape or form. I like those to report themselves to the same game object, because that way you don't end up with like one massive, pretty hard-coded save game function in here. So let's go back to our quest tree here in a quest manager. If we open that up, we already have something where we're adding the quest assets to the finished quest array, which might be useful, might not be useful, depending on like what you want to do. But why not also use this exact same place in the code to add itself to the current save game object? It's nice to just have the save game object existing in memory so that we can do that. So let's get this game instance reference that we already made before and get the save game object that we just created. And from there, we can get the finished quests and just add to it. Just to be sure, though, do use the add unique, because there's no use in adding this multiple times. And just slot that in between there. For assets, it's very easy. We have this quest asset reference already, so we can just get object path as a string, and that lets us save references to assets in a save game, because we can use this string later on again to load that object from a string and get a reference to that asset again. You can't directly save assets because they're memory address pointers. So this way, whenever a quest finishes, it reports itself back to the save game object that it has finished. And that's kind of the way that we're going to do the individual tasks as well, but that's going to be a little bit more involved, a little bit more complicated, because it's going to need to update pre-existing parts of that array. Speaking of which, while we're still in the quest manager, when we add this information to the quest display, we also want to create this in our save game. But, and this is the kicker, we only want to do that if our quest doesn't already exist. Because if our quest already exists, we are just going to assume that our save game knows what's up. And this is where I kind of skipped over something last time, because we do want this other branch here of this for each loop to also hook up to this adding node, but there's going to be another adding node in between that it's not going to hook up to. So I made a little bit of a mistake here. Just hook it up now and pretend like I didn't make a mistake. So we'll get our quest game instance, we'll get the save game object, and from there we'll get the progress, and to that we will add, or add unique. In this case it doesn't actually like matter that much. We'll split structure bin and we just put in our quest ID. Much like the other one after it that we made before, we don't really need to give in the tasks themselves, because the tasks are going to populate that when they get added by the task manager or by the task creation, depending on how you have things set up. For now, we just need to make sure that this array has an entry with this quest ID. This is where C++ would also be nice to work with, because in C++ we could set up a way to like find item based on only the quest ID instead of the entire struct. in our case, what we're going to need to do is we're going to need to loop over the entire thing and compare quest IDs, which is essentially the same. Quick little cut in here during the editing. You're going to see me using this quest progress in this for each loop. That is a mistake. What we need to do is we need to get the save game object and get the progress from there instead. So what we're going to do is we'll recombine this structure pin, disconnect this, connect this up, split structure pin, and you'll see the difference here. The array element tasks is going to be a dark blue for it being a struct instead of a light blue, which is for object references. So that's how you can see the difference between those. For the rest of this segment of the video, you're going to be seeing this as light blue, but that's because I used the wrong array here. So you don't want to use the quest progress immediately from the game instance itself. What you want to do is you want to get the save game object in there, and from there get the quest progress. However, you still want to use the normal quest progress array for adding the name and quest ID at the very end here. So let's go ahead and set that up. Go into our objective manager, and here all hell is going to break loose. I'll make a little bit extra room because we're going to definitely need that. Here, the very first thing that I want to make is a new function, something like task ID already in save progress. Very long name, very descriptive though. There's going to be taken in a task ID, which is going to obviously be a GUID. And then also it's going to take in an array of our tasks, which is going to be the task status save. And that's going to be an array, as I just said. So we'll, for each loop over that, and then as per usual, what we do is we split the structure pin, and we are now going to compare this task ID to the task ID that we give in. And here we essentially just check, hey, this condition, does this array that we're given in, which is going to be taken from our save data, already contain this task? If it does, what we do is we return, and we're going to return with a couple of outputs. So we'll do a whether or not the ID was found, and that's going to be a single bool. And then we'll also return whether or not the task was finished. So let's add in our return node. And obviously, if we have found an ID, the ID is going to be set to true. And then whether or not it was finished is going to be the element array task status. Because it might have been, it might not have been. The only thing that we know is we found the ID and we're going to be returning whatever value was associated with that ID. If we complete the entire loop without finding anything, of course, that means that we didn't find this ID, so it doesn't yet exist. So in here, inside of our for each loop, after we bind to objective finished, we're going to check, hey, does this task ID already exist in our save game object? Yes or no? And we'll do that by getting our array element and getting the task ID that we set up way back in the first video. And then we'll have to put in an array, and the array that we're going to be putting in will be from our game instance, get save game object, get progress, and then we're going to get a reference, because we're going to be updating it in a moment, of a certain index. We'll get back to that in a moment because we're going to be creating an event that actually keeps track of that index in a second. But from that, we'll break and get our tasks array that we can put into this function. If this ID was found, what we do is we get our object and we set our task finished. So set task finished just to whatever the task finished value was, because apparently it already existed, right? But if it wasn't found yet in that array, what we're going to do is we're going to be adding to that array our own task ID, which we get from here. You might need to make a little bit of room to keep this being somewhat readable. Split structure pin, of course, providing that task ID with the status of just nothing, because if you're just adding it, you probably haven't finished it before. I'm going to just take all this code that we have here and just pull it down a little bit so that it's a bit more visually readable. We have a little bit more room to work with. So add in some things like some reroute nodes here, so we can reroute this and make it look a little bit better. and maybe move all of this over a tiny bit as well. Add in a reroute node here, reroute node there. Just like a little bit of visual cleanup to make it a bit more readable. Now, for all that to work, we do need to be able to get the index in our quest progress. And the reason that we need to make that into its own like separate little function to run and update is because this happens whenever we originally initialize these objectives with the objective manager, right? But if we finish a different quest and the order of that array gets updated, before we then go back at a later time and check this stuff again, the index might have changed. So anytime we need to get this index, we need to kind of like rerun that code. So the way that we do that is we make this into a function, get index for quest ID. And we're going to make this a blueprint pure node. That's going to make it one of those green nodes, and that's just going to run whenever it's called without it needing to have like execution pins. And what this is going to do is it's going to take pretty much this whole string, so this game instance, save object, quest progress, and it's going to, for each loop over that, and to nobody's surprise, it's just going to compare all the quest IDs, which you do need to like split structure pin for that. It's going to compare all the quest IDs to the quest ID that we are working with for this specific quest. And when it finds that, it's going to return the index for it. So we set that to an integer, and we simply return the array index. And that's also then going to stop the rest of the for each loop. So that's built in with the return node. And now we can just use that get index for quest ID and put that in there. And then one last thing here is after this for each loop with break, once this completes, I do want to check, hey, did we also just initialize this entire thing with all the tasks complete? Because that very well could be the case, because we are potentially setting like task finished here from our save data on all of the tasks that this thing is managing. So if we've done all of that, we want to say, hey, that actually kind of means that we should move on to whatever is next. So we do that at the very end here with a branch, and then we're going to just, when this is true, we're going to finish this task, and I'm going to set succeeded to being false, just in case we want to like reward somebody with a reward when they finish a part of a quest, like one of the states itself. We can do that now based on whether or not they succeeded or they failed. And this is going to still complete this state, and this is going to be a little bit of information that we can use on, hey, was it a successful completion? Meaning that, are we going to need to like give the reward or not? Which can be a nice way of doing things. So that is pretty much setting up all of the saving part of things. Again, these objects are going to report themselves to the save object. So the save object itself and the game instance itself doesn't really have to do anything on save game, aside from just save game to slots. It's going to take the save game object that we have here, and the slot name will be just quest for now. You can of course make an entire save system with like different slot names, but that's not really super relevant right now. I'm going to add a print string to this that just says saved for our own feedback purposes. Loading the game is going to be a tiny teeny bit more complicated, so let's get into that. So when we load game, first we want to check, does save game exist? We're going to check whether or not the quest save game exists, of course. And if it doesn't exist, we are not going to do anything because there's nothing going to be like there to load, obviously. But if it does exist, we will load game from slot. Again, that we're going to be loading will be the quests, and we need to cast that to our save game for quests. After we've loaded that, we're just going to set our save game object variable that we have here to the newly loaded one. That means that the one that we created in the beginning here is going to eventually get garbage collected and deleted just for us, but we want this new one to be the one that we're going to be working with going forward. Then we're going to use this now to get our finished quests first. This is going to be fairly straightforward, because what we do is we for each loop over that. And we're going to take every one of these strings and get the corresponding asset for them and add them back into our finished quest array. So the way we do that is we get the assets registry, And with the asset registry, we can get an asset by object path. Now, there's two of these. I'm going to go with using the top one, and you can just pull through this string into this name variable. And that will get you a struct for asset data. If you pull over this, you can just get the asset, cast it to a state tree, and now that it's a state tree, we can add it to our finished quests array. So get the finished quests, we add unique as per usual, put it in there, and this is now going to repopulate our finished quests. Now, there is an argument to be made that we do want to, at the very start here, maybe like clear this out so that it doesn't maintain quests that we might have been like completing on a previous save file. Well, this is pretty much everything there is to it, because everything else about saving this stuff we already did. Because of the objects reporting themselves to the existing save game object, and also using the save game object to like pull data from, we don't need to like explicitly add any saving or loading for every one of those pieces of data, because they're already integrated with the save game object that's currently in memory as the active one. So now with all of that set up, let's go into our third person character and add a couple of debug keys for all of this. Let's do debug key F and debug key like L for load maybe. And this is going to, in both cases, get the game instance, cast to our BP game instance. It's going to do this for both. So let's just copy this over real quick and hook all of that up. And in the case of L, it's going to load game. And in the case of F, it's going to save that game. Now, this doesn't quite work yet, because when we load the game, quests don't know that they need to activate. We'll have all the data for them to activate with, but we still need to like activate them. So what we do, go into the quest giver blueprint. So let's just open it up right here. And there on begin play, what we'll do is we will get our third person character, cast to that with the get player character. And then the third person character itself is going to make a little bit more room in its code. So that's a little less crammed in here. When we load the game, I want to just send out an event dispatcher game loaded. Maybe save game loaded, whatever. And we're going to call that out whenever we load the game. That way, we first load the game, all of the data will be in the right place in the game instance, and after that it's going to call out to anything listening to this, which is going to be all the relevant quests, that a game, save game has been loaded. So we can then use that in here to assign to game loaded, where we can get the game instance, of course, cast that to our BP game instance. Again, this is probably why you want to make like a blueprint function library for this, because this gets tedious to do real quick. We get the current progress of everything, and we for each loop over that. And for this one, I'm again cutting in during the editing, because I'm getting the game instance here, casting, and then immediately getting quest progress. Of course, this quest progress is going to be set by the tasks within this quest, so this is going to be empty until the quest is started, and we're using this to see if the quest should start. So the issue here is we need to get the save game object and get the progress array from that one. It's a little confusing having both a quest progress of one type as just an array on the game instance, and having a slightly different type quest progress on the save object. So that's why I'm cutting in a couple of times during this video, because I also messed it up while I have a reference on my other monitor of how I set it up before. So if you get a little bit confused between the two of them, don't worry, it happens. Anyway, so you instead use this one, so you recombine this structure pin. If you need to refresh node to make it gray again, hook this one up into there, and then split structure pin again and get the ID from there. You'll also be able to note that aside from this one being sometimes light blue, you also shouldn't be getting any of the name stuff in anything that is supposed to save or load from save or write to save, because we're not saving those names to save files. That's entirely unnecessary to do. And we're going to be splitting that trying to get the quest ID. But now we run into the issue again where we can't get the quest ID from our state tree inside of here. Because you can set things in the state tree. Like we can just go in here and we can like set these values. You can't get them though. Unlike behavior traits, whatever, where you can get like variables by name, state tree doesn't really like allow you to do that. So what we do instead is we just store the quest ID on the actor itself. So if I do quest ID here, that's going to be our GUID. Most extra thing is that this way we can technically automate generating the GUID, which I'll do in a moment. So if we go back into our quest here, instead of having the quest ID existing on here, we can delete this in a moment. What we're going to be doing instead is we'll refer to our quest ID anytime we need it, which is going to be in this like objective manager. From our schema, set this to BP quest giver. Compile that real quick. And then the quest ID we can get from our actor quest ID instead. Same here. We can get that from actor quest ID. So we don't need to generate it anymore on the actual tree. So now that we have the quest ID on the actor, we can check against it on the actor for if it exists in our save data. And if it did exist in our save data of currently in progress quests, we, of course, start the quest. So now we set the quest GUID to being exposed, just so that we can set it easily from the editor here. So now you will note that we don't have any quests. I pick up this first quest. We see walk to location 2. We do one of them. It's marked as being completed now. I press the F key to save and restart the game. No quests are available. I press the L key to load, and now we can see that we almost are there. It doesn't quite set up the completion state of our objectives yet, but it does properly load in what quest existed in our list. And the only reason that that happened is because we don't have the task IDs set up yet. So we just need to go through these and set up these task IDs so that they have a unique ID that the save system can take advantage of. And then in here in our objective manager, when we finish an objective, we also need to update that in our save data now, not just as part of the object itself. So what we do is we move this old task complete check away, because we're going to for each loop with break, because why not, and hook this up with the completed pin. And we're going to need to be looping over effectively this exact same setup again. So we just pull this in down here, and this is going to get the corresponding ID for whatever is relevant at the time of execution here. So that's why we make this that pure node. And here we just break, and here we just check for every single one, and we'll check here if the task ID that we're looping over is the same as the task ID from the objective. So this is why very early on we made this objective reference part of this event dispatcher, because now we want to be able to check, hey, the thing that we just finished, we want to kind of fish that out of this array. And again, because we're not working with C++, we need to actually like iterate over entire arrays to do this. So once we have found the corresponding task ID, which realistically isn't going to be that much, by the way, because there's only going to be a couple of tasks in any given quest, what we'll do is we'll pull off of this again and get a reference, specifically, not a copy, a reference, to whatever index we are on. And then we set variable by reference. Here we'll split the structure pin, and we'll set this value to true, and then the task ID will of course just be either this task ID or this task ID. These are going to be the same because that's what this node is checking to begin with. And then once that is done, we can break the for each loop because we have found our match and updated it. So this will update your save file information as you complete objectives as well. So now you can see if we go through, we have no quests active. Now we have one quest active. Now we have a quest active with one objective solved. If I press the F key and I restart the game, you can see no quest again. But if I press the L key, we can pick up where we left off. So we now have a functional save system. Believe me, I know that this is confusing. There's a lot of things that are very much alike and that are easy to get like cross-wired. Like I said in another earlier cut-in in this video, even while having the reference that I made earlier this week open, I made a couple of mistakes of taking one array instead of the other, and it's entirely natural to make a couple of mistakes with all this stuff. But we effectively now have a quest save system, which is like quite important. So from here on, we can start expanding a little bit, and maybe we need to come back to this save system and tinker a little bit with it if we're going to expand it into having different types of tasks that might need to have different information that gets saved, but the same like things apply to it. Like every location that we've been here for like setting and getting from that save file, effectively all that we need to do at this point to add stuff to it is go into that blueprint struct, which I think it's like this one, right? And we can add stuff to this, and we can just like read and write from that in like the couple of different places that we're working with this. This is the downside of working with save files the way that I like to do, which is creating one that just exists in memory that you can access for writing or reading to, because it is a very decentralized way of working, so it is easy to get lost a little bit. But for some of the parts that we're doing here, it's really the only way to get the information from these states in the state tree into our save objects, because it's not information that can be requested, only information that can be given. So for the next part, I think we're going to do something a little bit lighter. We're going to just make a couple of different types of objectives. We at this point have only been like going from location to location. I want to show you how you can set up your own like custom actors that have their own like custom objectives that you can bind to instead. Alright, with the scariness of a viewing system and then especially the save system behind us, let's do something a tiny bit more fun. I want to just go through and make a handful of different types of objectives to gather up. So this is going to do two things. Number one, just show you how to set up an actor with a delegate on it that you can bind to that isn't provided you by the engine. And number two is I want to look into making our tasks a little bit more complex to be able to handle tasks that have progression to them. Because right now we only have tasks that have a concept of, hey, I am finished or I am unfinished. But what if we want to have a task that has a certain percentage of potentially being finished? So let's take a look into that. The first of which is I'm going to make this something like a stand-in for an enemy. We're slowly starting to like grow out of proportion with the amount of blueprints that I have within this project without sorting anything to folders, but we'll be fine. I'm just going to make this BP enemy, and the enemies are going to be cubes because I don't really think that we need to go over like modeling entire enemies and like making an entire combat system. That's super not the point here. These are going to have an event dispatcher called something like onKill. Just for the sake of making this flexible, I'm going to add in here an input for the enemy type, and that's just going to be a BP enemy class reference. So if we have multiple different types of child classes of this enemy, it'll actually send through what type of enemy was killed. If you have a specific task to kill a specific instance of an enemy, that's something that we can do. But we can also make it so that you need to hunt down a specific amount of a specific type of enemy. So we're going to make tasks to do both of those things. But let's say that we just have a custom event here for kill enemy. That's first and foremost going to call out its onKilled event with a reference to self. You can just put that in here, or you can't actually do that. You need to get class from it, and then you can put that in there. It works as well. And then we will just destroy this actor. Now, in order to kill these enemies, I'm still going to make them just like when we overlap with them, they're going to like die. So it still will be kind of like a location event. But of course, if you have a combat system in your game, you would tie this into like when you attack an enemy and its HP is under 0, it calls this kill enemy. For now, we just do is a soft third-person character kill enemy, right? Which means that we also need to add something like a sphere collision or something at least somewhat similar to it. So we can put these in the level now, and if we walk up to them, they will die. But let's make a task that looks out for a specific enemy to be killed. So we can go back into, like, let's do in quest number 1. We have an objective to go to 2 locations, but we'll also now make an objective which create basic objective is going to be its parent, STT, kill enemy. which is going to do something similar to the other things that we did. Instead of making a new function, which I did by accident, you're going to go enter state, you make a variable for enemy to kill, which will be a BP enemy reference, and you simply just assign unkilled, at which point you get the task, or you get the objective rather, this task that we have here, and we finish that objective. Quite as easy as that, really. So now we can go back into quest 1 and add a new objective here, so we can get a kill enemy objective, which do make sure that it is above the objective manager, because it might start acting up weird if you create it afterwards. We're going to be adding it to the objective manager, so we just add a new index here. That's going to be STT kill enemy quest objective. Name is kill the wolf. There's no wolf there, just a cube, but let's just pretend like it is. You add a parameter, and this parameter is going to be of type BP enemy. Object reference, we generate a task ID, that's important. And then don't forget to set the enemy to kill to being an input. That's something that is easy to forget, but it needs to be an input because otherwise it doesn't show up here. Go to parameters, new property, probably give it a name, like enemy1. And make sure to call parent function as well. That is, again, another thing that's easy to forget, but you do need to do that because the parent function is actually the thing that sets up this quest objective object. And now you can see, if we go into the world, and I open up the quest, we now have walked to location 1 and 2, but also killed the wolf. So if I now go up and kill the wolf, we'll have killed the wolf as part of this quest. So that's number 1. Now task number 2 would be keeping track of how many enemies we have killed of a certain type. So let's actually make a couple of different ones here. Let's actually not delete this first one, that's fine. And then BP enemy, we're going to make a child blueprint, and that'll be BP enemy child 1. And we'll change this to a different material maybe, like this one will be grey. And we'll make a BP child number 2, which it automatically names properly, that's fantastic. And that's going to have yet another material, and this was just going to be entirely black, why not? So then, now that we have a couple of different ones, what we can do is I can go back here into my blueprints for my third-person character. And what we're going to do is I'm just going to make a custom event here real quick, kill enemy, which is going to have an input of type kill with a BP enemy class reference as the type. And then we'll also make an event dispatcher on kill enemy existing on our player character. That's just kind of going to forward that to whoever is listening. So we just make this new param, enemy type, and whenever this killed enemy is called, we just forward that information to whoever is subscribed to this event dispatcher. So now in our enemy actor, instead of just killing the enemy like this, what we'll also do is we will get the other actor. And in this case, we're actually going to need to do a cast to third-person character, because we're going to call the kill enemy with our class reference to self. And then we'll actually do the kill enemy still as well. So now let's go back in here and again make a new task, create basic objective, and this will be STT kill enemy by class. We'll override enter states. We'll call the parent function. In this case, we'll just get the player character, cast it to a third-person character, and then assign on killed enemy, which I also misspelled. Just ignore that for the time being. Whenever we do that, we just check if whatever we killed was of a certain class, which we're going to promote to variable class to kill. Now this is going to be a object by default. We're going to change this to specifically a BP enemy class, so that's a little bit easier to pick out, and we kind of just set that to being exposed. And if the thing that we just killed is the class that we're looking at for to kill, we get objective, which is down here somewhere, and we finish objective. So it can really be as easy as that. So now let's add in yet another one of these, kill enemy by class. We'll say kill the grey one. I think it was enemy chart number 1 was the grey one. Yes. We'll give that task an ID. Make sure that it happens before the manager task as well. And then in the manager task, we add in a new task to look at, kill enemy by class. And now that should be added as well. We don't even need to add anything to these parameters because it's just looking at the player itself directly, and just every time the player broadcasts, hey, I just killed something, it's checking, hey, did you kill the thing I care for? If so, we're going to be moving on. So it is actually even easier to set up than most other things. So if we now do this, we can see we have killed the grey one. If I kill the black one, for instance, it doesn't update either of the other ones. If I kill the white one, that's referenced by instance, so it kills the wolf. If I kill this grey one, it kills the grey one. But let's say that we have another grey one over here. Because we're not referencing a specific instance, but we're just checking, hey, the class that we killed, is that the grey one? I can kill this one, and it works all the same. So of course the next evolution of this is to make this a variable on how many we need to kill. And for that we do need to go back and change a fair few things here. So let's take a look at that. The very first thing that we're going to need to update here is the quest objective itself. We'll see here the progress for this objective, and we'll make that a float. This is effectively always going to be a 0 to 1 value. Finish objective is going to stay the same, but we're also going to make a update objective instead. And when we update the objective, what we're going to do is we're going to set our progress to a new progress value. So this will be, let's just call this new progress. And if this is now greater than or equal to a value of 1, then we will finish the objective. So we're never going to be calling finish objective anymore directly in any of our state tree tasks. We're just going to update the objective, and then update objective will take care of, hey, do I also need to finish this? The only real place that we need to start updating is location objective. Obviously, that's always going to be a 0 or 1 type of deal. The kill enemy by class is the one that we're working with. This is where we need to start looking into, okay, when we kill an enemy, instead of just finishing the objective right away, what we need to do is we need to keep track of kill count, and that's going to be a integer. We just pull that in and we increment that whenever we kill something that is the right kind. Then we also make a new one for amount to kill, which we will make instance editable. We'll expose that. And then here what we do is we get our kill count and our amount of kill that we need, both. I'm going to do a to float for both of them, just because we're going to be dividing them to get a decimal, and it's easier to just convert them to a float to begin with there. And we take this amount of kill that we need, and we divide it by the kill count that we get, and this gets us a 0 to 1 value of how much progress we have made. So we just update objective with that new progress. And we don't need to do any of the finish objective logic in here because the object takes care of that for itself. So now if we go back into quest 1, kill by class, it should have an amount to kill. Let's set that to 4. And it's only going to increment that when we kill the gray cubes. So let's add a couple more gray cubes just to show you. So I'll just put 4 of them here back to back to back. We pick up the quest. It has killed the gray one. Well, it's actually 4 of them. Now if we interact with this, it already does seem to be finishing it. Don't listen to what Past Me said. Past Me is very annoyed with all the noises going on outside. You need to turn this around. So you divide your kill count by the amount that you've killed so far. I did it the wrong way around before. So now we should be able to see, we pick up the quest. It says kill the grey one as one of the objectives. We kill 1 of them, nothing happens. We kill 2 of them, nothing happens. We kill 3 of them, nothing happens. We kill 4 of them, it's now crossed off as being done. So it's counting up toward whatever amount you need to do in total. So from here on, you can do that with items, with these enemies. This honestly is closer to an item pickup system than an enemy killing system, obviously. We just need to be able to save and load that data along with whether or not the task has been finished in general. So for that, and maybe be able to display it as well if you like really care about that, which you probably do. But let's open up our task status save here, which has our boolean and our GUID. So we're just going to add in a progress value that is a float. Open up our objective manager class here, and you can see now we have this set progress value. So whenever we finish a task, that obviously means that we set it to being a value of 1. And if we're going to do this, we do need to also update it anytime the value updates. So we do need to go back into our quest objective itself and make a onUpdated that we need to call out. So we do onUpdated, which is going to have a input parameter for the objective. We could also just push through only the new progress flow, but in case we have other information to update down the line, it's better to just push through a reference to the object as a whole, which is of course going to be our quests objective reference. So we call that with a reference to self whenever we have updated this value. Now, going back into the objective manager, this is when we finish the event, we do all of this. So now what we do is we also bind on updated. And what we're going to do is we're going to kind of replace this, to be honest, because we don't really need to do any of the objective finished anymore, because we're going to update all this whenever the objective gets updated to begin with. The value progress we're going to get from this objective as well. So task ID, we also get finished state on whether or not it's now finished, and get the progress. At this point, it might be good to start like organizing the blueprint a little bit better, because it is starting to be fairly messy all over the place. But this will take our current object values and put it into our save array. And then we're going to have our update event bind to that, and we're just going to get rid entirely of the objective finished event dispatcher. And since we do that, we do need to make sure that we call this onUpdate at the very end of this actually. So we first do our check, then we finish objective, and after finish objective, we call the onUpdate. And if we don't finish objective, we just call onUpdate anyway as well. So now is a good time to test out whether or not that still works the same way. So we pick up the quest, kill the gray one, 1, 2, 3, and 4. That still works. The other ones also still work. If we kill the white one, there we go. If we go to our location, that also still works. So everything still works the same way, except that we're now also saving our progress values on this. The only thing left to do is to also load those values, and that's what we do over here. So we set our task finished to whether or not our task was finished. But we also use this exact same object, which is a object from our objectives array, to then set our current progress. And the way that we're going to get that current progress will be from this task ID already in save progress, because right now we're only returning whether or not it was finished or not. What we're going to be doing instead is I'm going to just return the entire struct. So we're not going to be using was finished anymore. What we're going to do instead is I'm going to disconnect everything about this. I'm going to recombine this structure pin, and we're going to just put that as one of the return pins. Then we'll also add in a break node for it, because we still want to be comparing this ID, of course. And then was finished we'll also get rid of, because we're going to just, again, send through the entire struct. Makes it a little bit more future-proof, because if we add more stuff to this struct, it'll just send through the entire thing. So was finished will disappear as well. That doesn't matter anymore. We just pull this thing out, we break, we set our status, and we set our progress like this. So this is the loading side of the entire setup. So now that we have that, we just need to go back into our task that keeps track of doing those enemy kills, because that's going to require a slight change. So where before we were dividing our kill count by the amount to kill, what we're going to do instead here is we get our amount to kill and divide 1 by that amount, and then we just get our quest objective's current progress and add those two together to get our new progress. Because that way is going to be adding a 1 over x portion to whatever we already have in there. And now you'll notice that if I start the quest. We have the quest. Let's say I kill 2 of these grey ones. I save. I back out and I start again with loading. Quest isn't completed yet, but if I kill 2 more, now the quest is completed because it also saved my progress between play sessions. So with that, you can now effectively set up the quest however you want. Get this amount of this item. Kill these specific instances. Whatever you want to do for your quests, you effectively now should have the tools to script out and program effectively any sort of objective that you could think of. And because this is all related to assets, I might add, the only thing that isn't quite related to the asset as far as identifying these quests goes is the GUID on the quest giver actor itself. But if you just copy that over to another instance of this in another level, progress for these quests can very easily just persist between levels. If you want to have a quest that's given in one level and has an objective in another level, you can just copy over the GUID and the stage tree itself and populate one of these parameters in an entirely different level. And then when you come back into this level, it should have pretty much all the progress saved between different levels as well. As a fair warning, I haven't tested that very thoroughly with this system, but there shouldn't be any reason that necessarily would mess up, as far as I know. If you want a more in-depth and slightly more flexible system in some ways, I still do have the object-based one, and I honestly do think that if I were to go ahead and make quests for a game, this is a lot more readable in a lot of ways because it's using the state tree interface. I think I would personally use the UObject-based one that I made before because of its flexibility and the way that it can infinitely nest stuff. And it's really quite neat, but it is a bit more complicated to set up. So if this does what you need it to do, it's a fine system if you want to dive in a little bit deeper and create something a little bit more semi-advanced. I think that this is still a good step up. Getting all of this to work, making you understand how these UObjects, the basic objects that we're working with, work. And if you want to progress to the UObject-based quest system that I made in the past, this will be a good lead into that anyway. So hopefully this has been a helpful thing. The entire series project files, of course, will be down below in the description as always. And next time we'll be back with something else, a lot of fun. I think for the time being, we've had a lot of state tree fun. I think we're going to do something a little slightly different. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And of course, an extra massive thank you to my Cave Digger tier supporters, Sergey Thomas, Mauricio Farias, and my Cave Student tier supporters, Oiku and Earl Monsville Urno.